Jai Gurudev student, good morning. Today we are starting with the last part of this chapters, and last part of this chapter is your batteries. So battery, first of all, what is battery? One or more cells in series is called battery. So if you have attached one or more cell 1.5, 1.5, 1.5, so whatever you do in the torch, two or three cells together in series connection gives you what is called battery. So battery are of two types. One is your primary battery, another one is secondary battery. Primary battery cannot be recharged. Once the cell reaction is over, it becomes dead. The primary battery, for example, dry cell, the cells that are using the torch, that is your dry cell, which cannot be recharged. So once the cell reaction is over, you cannot reuse again. But the secondary battery student, so what is the difference? Cannot be recharged, can be recharged. It is layered storage battery. The batteries that we are using in inverter battery, all these things can be recharged. So after that student, we are starting with primary battery. So primary battery is, first point is your dry cell. So this is your dry cell. Now with what it is made of? First of all, this is your carbon rod. The black color rod is your carbon rod, and which act as cathode. Your zinc rod act as anode. So your electrolytes are MnO2, C black means carbon black, ammonium chloride paste, and zinc chloride. So these things are there. This is your zinc rod anode and carbon. This is your cathode, and this one is anode. In between that, we have MnO2, carbon black, NH4Cl paste, and zinc chloride. Now student, in dry cell there are reaction at anode. Zinc converted Zn dipositive plus 2 electron. So if I have used the Lone method, so whatever may be the anode, LOAN, Lone, if I use that one, so in anode we have oxidation. So zinc anode undergo oxidation as Zn dipositive and 2 electron. Reaction at cathode. In cathode we have MnO2, in this one MnO2, NH4 positive. So from NH4Cl, so this is your NH4 positive and Cl negative. We are taking NH4 positive and 2 electron that is comes from the anode gives you MnOOH plus 2 NH3 gaseous. So these are the reaction at anode and reaction at cathode we have to learn. Now some question arises from this one, why this is called dry cell? So answer is that the electrolyte whatever we have used there is in the solid form. So this is why this one is called dry cell. The dry cell answer you can give. Cell potential of this one, if you go through those batteries, you will get 1.5 volt. And what is the role of zinc chloride? What is the role of this one? So zinc chloride reacts with the ammonia gas produced in the reaction of cathode. Otherwise, ammonia gas, lots of ammonia gas produced that may crack the cell. So ammonia and zinc chloride react to form a salt. So that is why the role of zinc chloride is that to reduce the pressure from ammonia gas. So why dry cell become dead if it is not been used for longer time? So dry cell become dead if it is not used for longer time. For example, if you have in the cell we have ammonium chloride which is acidic and that react with the zinc casing. So zinc chloride, ammonia gas, all these things produced. So this makes the cell porous because zinc casing outside and ammonium chloride inside, they will react and make that one porous. So that is why this cell become dead if it is not used for longer time. So in this page what we have learned, we have two types of cell, primary cell, secondary cell. Primary cell cannot be recharged, secondary cell can be recharged. In primary cell we have learned dry cell. In dry cell cathode we have carbon dot, anode we have zinc casing outside, and electrolytes MnO2, carbon black, ammonium chloride paste and ZnCl2. Now we have also learned that some reactions are there. Zinc at anode converts Zn dipositive 2 electron in cathode, MnO2 ammonium ion and electron forming MnOOH and 2 ammonia. Now we have learned that the dry cell is called dry cell because the electrolyte present in that one in the dry condition or solid form. Cell potential 1.5 volt. Another point about the cell potential, when the cell reactions are going on, so it is the potential is decreasing so long as the reactions are going, ionic reactions, the concentration of ions decreasing. Role of zinc chloride react with the ammonia gas forming salt. The pressure of ammonia is reduced by zinc chloride and the cell become dead even if it is not used for longer time because acid NH4Cl corrode the zinc casing. So now we are taking the next one. So these points you student, you just note down, these things are very much important. So we are learning next cell is your, this is another primary batteries. This one is mercury cell. This one is also called button cell, BUTTON, button cell. So it is used for low current devices. Used for what? Low current devices. So it is used for low current devices. For example, hearing aids devices, the batteries used in those hearing aids or watches, etc. So this is your mercury cell. In mercury cell, the cathode is your paste of mercurous oxide and carbon. Anode is zinc mercury amalgam. The LOF made from mercury is called amalgam. Electrolyte, a paste of KOH and zinc oxide. So these are the, actually in batteries, these 3 points you have to learn. Point number 1, what is cathode, what is anode, what is electrolyte. So in this cell, the overall reaction is zinc mercury amalgam and mercurous oxide. The mercury oxide cathode and zinc mercury amalgam from anode react with another zinc oxide and mercury. And cell potential is 1.35 volt. Now in this one, if you have go through the overall reaction, there is no ions involved in the overall reaction. If ions are not involved, their concentration are not going to decrease or increase. That is why cell potential remain 1.35 volt through lifetime. Now we are learning the another point, is secondary cell. Secondary cell, as we have discussed, these are the rechargeable. In that category, first one we are taking lead storage battery. In lead storage battery, I write in lead. The anode is your lead. Cathode is the grid of lead packed with lead dioxide. Grid of lead packed with lead dioxide. The figure, student, also you have to go by the book. You have to go in the book. There is figure is there. Electrolyte is 38% H2SO4. So these things we have to learn, that what is cathode, what is anode, and electrolyte is 38% H2SO4. So anode is lead. This is the lead packed with lead dioxide, and then 38% H2SO4. So from this, the next point is that in lead storage battery, we have some reactions. Reaction at anode. Anode already have discussed, we have taken lead. Reaction at cathode, we have discussed that we have taken lead oxide. So lead react with SO4 dinegative. SO4 dinegative comes from H2SO4. So that one PbSO4. 2 negative means 2 electron. 2 electron you have to show in the right side. PbO2 SO4 dinegative, 2 electrons got from the earlier equation, and 4H positive. In total, student, if you have go through these ions, then 4 hydrogen SO4 SO4. So that gives you 2H2SO4. Now PbO2, that is at cathode, react with the 4H positive and SO4 dinegative 2 electron PbSO4 plus 2 water. If you add those two reactions, overall reaction, then what we have, 2 electron goes. So if you add this one, Pb plus PbO2 plus 2H2SO4, if you add them, that gives PbSO4 means twice PbSO4 plus 2 water. Now student, this is the left hand side reaction, these are the right side reaction. So student, one point we require to remember, that when we have no electricity in our home, then this reaction takes place from left side to right side. This is called discharging. And when we have electricity in our home, then the reaction takes place in the reverse way. This is called charging. So what happens in those batteries? The anode becomes cathode during charging, and in discharging the same process, cathode become anode. So this reaction takes place like that. Now one more point that I want to tell you, that we know that we have to add distilled water. The water required to be added time to time as it is lost during electrolysis. Student, you remember, we are using anode, cathode, we are passing electricity, so electrolysis will take place. Due to electrolysis, hydrogen oxygen will produced, so hydrogen oxygen will evaporate, and due to this we have loss of water molecule takes place. That is why we have to add distilled water time to time. Sometimes we have to add the acid in also in the batteries that we have used in the cars and all those things. Due to mishandling, they may tilt it like that, and due to this, some acid may fall down. So next, another thing is that nickel cadmium cell. It is a costly. It is actually not commonly used. So nickel cadmium cell, in this one, cathode is your nickel oxide, anode is your cadmium, electrolyte is KOH solution. So overall reaction in this one, your cadmium reacts with 2 NiOH thrice nickel hydroxide, gives what? Cadmium oxide, 2 NiOH twice, and water. So these things you have to learn for this one. Okay, next point we'll take in the next video.